Hello everyone. In this video, we are going to see about linked list. Linked list is the linear data structure. Here, data are stored in the format of node. Node will have the two parts. One is the data, another one is the pointer. That pointer is generally called it as a next. The next will have the address of the next node. Okay, let me draw and show you how the data is stored in the linked list. So this is generally called as a node. This portion is called as a data. This portion is called as a next. The next will store the address of the next node. Here we will store the data like this. Here we will store the address of the next node. For example, we are having one more node like this, and this also will have the two part. This part is data, this part is next. Let us assume the address of the first node is 1000, address of the second node is 2000. So the first node, node 1, will have the address of the node 2. What is the address of the node 2? 2000. So it will have the 2000 over here. So the meaning that it is connected like this. Let us assume this 2000 node having data is 30, and the next there is a no node after the node 2, then this will be assigned as a none. Okay, so linked list means each node will be linked by the next node address. That is the reason it is called as a linked list. Okay, so each node will have the two part. One is the data part, another one is the next part. Next part will have the address of the next node. The last node always will have the none or null value. So how do you find the last node is how can we find the last node? It will have the none in the next part. Okay, so according to the access strategy, linked list is the linear one. According to the storage, it is a non-linear one. See, by access we can access one by one linearly, but storage it may store in some other place like 1000. Instead of 1008, it is stored in the 2000. So it is called as a non-linear one. Application, it is used in many places to implement the stack and queue and a graph application and browser application and music player, image viewer, and so on. Okay, let us see how to represent the linked list. Okay, this is the linked list. You can see here we are having the many nodes. Let us assume this is the node 1, node 2, node 3, node 4. So node 1 is the first node. It is having the two part data and link. The data is 10, and here these are called as address. Okay, let us assume these are called as address. Node 1 address is 1000, node 2 is 2000, node 3 is 3000, and so on. So if you are seeing the node 1, this is next. Okay, it is not a L, it is a next. This is not L, it is a next. As I told, we can call it as either link or next. Okay, you can see the first node data is 10. First node next is address of the next node. What is the address of the next node? 2000. That is why it is having 2000. Node 2 data is 20. The next of the node 2 is address of the next node. What is the address of the next node? 3000. That is why it is having 3000. Node 3 data is 3000. The node 3 next is address of the next node. What is the address of the next node? 4000. And node 4 data is 40. There is no new node over here. So it is next of the node 4 is none. It is a none. If we are mentioning like this, we have to assume it as a none. Okay, do you understand? So linked list means the next will have the address of the next node. Then it is connected as a linked list. That is why it is called as a linked list. And we are having the one new node called head. It will have only one partition. It will store the address of the first node. What is the first node here? N1. What is the address of the N1? 1000. That is why head is having 1000. So head is linked into the first node. How do you know which is the first node? The address of the first node is stored in the head. Okay, so for your understanding, I will give you one more example. Let us have the linked list like this. We are having the 3 node. Okay, let us assume the address of the first node is 1000, address of the second node is 1008, address of the third node is 1012. Okay, these values, let me assume this is having 100, this is having 2, this is having 31, and we are having the head node here. Okay, let us assume this is the head. Okay, now we will see this is the data, this is the next, this is the data, this is the next, data, next. Now we have to find what is the next of the 1000. What is the next node of the 1000? This node. What is the address? Let me name it N1, N2, N3. This is address. What is the address of the N2? 1008. So this 1008 will be there in the next of the node 1. Okay, so it is linked like this. What is the next of the node 2? N2. That is nothing but N3. What is the address of the N3? Here let me take it as a 1016. So this 1016 address will be in the next of the node 2. What is the next of the node 3? So when I am giving like this, it is linked like this. There is no node in the node 3. After the node 3, there is no more node. So it will have the value none. It will have the value none. Okay, so this is the linked list. Now we have to give the head value. What is the head value? First node is N1. So it will have the address of the first node. So it will be pointing to the first node. So once we know the address of the first node, we can access the whole list. That is the advantage of the linked list. Okay, hope you have understood that one. And here some points are given. Linked list contains the link element called head. So every linked list there is a link element called head. Head will have the address of the first node. Node carries the data. Data will have the numbers or some data. And the link, this field is called as a next. The link field used to have the address of the next node. Each node is linked with this next node using the next link. Last node carries the null or none. Okay, so always the last node of next will carry the none. So this is the basic linked list. Now we are going to see types of the linked list. Generally linked lists are called as a simple linked list. So it will only move in the forward direction. Okay, this is the simple linked list. It will move only in the forward direction. Then we will have the doubly linked list. The linked list will go in the forward direction as well as backward direction. If it is so, it is called as a doubly linked list. Circular linked list means the first element will be connected to the last element. That is called as a circular linked list. Okay, what are the operations? There are generally 4 operations. One is insert, delete, display, search. Insert operations are, we have 3 options. Either we can insert the new node at the beginning of the linked list. Here we can insert. Or we can insert the new node at the end. Insert at the end we can insert. Or we can insert at the middle. Somewhere here. Okay. So 3 types of the insert is possible. Similarly, deletion, we can delete the first node, or we can delete the last node, or we can delete the any middle node. Okay, so 3 types of the deletion is possible. And display, we can display the complete list, and we can even search some numbers in the linked list. Okay, so these are the operations. We are going to implement these operations. Okay, first we are going to see the insert. Insert, we are having the 3 options: insert at beginning, end, and insert at middle. Okay, first we are going to see insert at beginning. First we must create the node. Okay, before starting the insert, the node should be there. What is a node? Node will have the 2 parts. What are the 2 parts? One is the data part, another one is the next part. We have to create the node like this. How can we create the node like this? With the help of the code we can create. Okay, I will tell you um, how to create the node in the code. Then we have to create the head. Why we have to create the head? Head will be pointing to the first node. Okay, these are the two things we have to do before the insert operation. Okay, let us assume we have created the node and we have created the head node. Let me give you example, then we will go into the code part. Okay, now please assume we have created the node. Okay, whenever we need, we will create the node, and head also will be created. Okay, insert at the beginning you will see. First we have to create the memory for the node. Okay, first if we want to insert, there are two cases are there. Okay, one is the case A. Let me give you case A. Insert at beginning, there are two cases. One is there is a known node in the linked list. The linked list is empty. Now I want to insert at beginning. So what I will do? First I will create the one node. First the node, whenever we need, we will create the node like this, and already we assume that head is there. Since there is a no node, head is having none. Let us assume there is a list is empty. Okay, initially list is empty means list is empty, so that the what is the meaning? The head is having the none. Now I am creating the one new node. Okay, so what will happen? This new node is addresses, let us take it as a 1000. If I am having creating the node like this, okay, what will happen? This node only will be there, so head has to pointing to this node. Okay, so here the none should come. Why? Since only one node is there. Okay, so we have to create the node like this. Then we have to change the head into 1000, the newly created node. So what will happen? Head will be pointing over here. So this is the case A. When there is a no node, just create a node, then assign the newly created node into head. This is what given in the algorithm. Create a memory for the node. Okay, just create the memory for the node with the data. Data is 10, and next should be head value. Should have the head value. What is the head value? Initially it is a none, so none will come. Okay, so the node will be created with the 10 and none value. Then we will assign the node into head. Okay, so what is the node? Node is pointing, this is the node. Node is pointing to nothing but 1000. So we are assigning the 1000 into head. So instead of the none, the 1000 will come. Hope you understood. First we have to create the node simply like this. Initially I will give you the one more time example. Kindly listen, because if you are not understanding it, then it is difficult to go to the next cases. It is a very easy case. Okay, so insert at beginning. Initially let us assume head is having none. Okay, follow the algorithm, create a node, create a memory for the node. So one node is created. So create a memory for node means node will have the two things. One is the data, another one is the next. One is the data, another one is the next. Okay, so data will have the some data like this, and assign next should have the head value. Okay, the next should have the head value. What is the head here? Head is none. So I am going to give node here. Next is node, next should be the head value. We are just think like this. We are giving like this. So what is the head? None. So this none value will come into this part. So node will be first created like this. This is the first step we are doing, step 1. Okay, node is created with the some data and the none value. From where we are getting the none value? From the head we are getting. Okay, head is giving the none. Second line, what we are doing? We are assigning the head equal to node. Okay, what is node? The address of the node. That, let us assume address of the node is 1000. So now the head is having the 1000. So link will be created like this. So that's it. So in the case A, when list is empty, one new data is node is created and this new node is linked with the head. That is the case A. What is case B? Case B. What is case B? Let us assume already linked list is there. Already having one linked list is there. Value is 21, 41. What is the, this is data, this is next, data, next. What will be the value over here? Address of the next node. What is the address of the next node? 1008. So 1008 will come. What is the value over here? This is the last node. So none will come. What is the head value? The first node address. What is the first node address? 1000. So 1000 will come. Okay. So we are having the linked list like this. Now I want to create the, I want to insert the node at the beginning. So what I have to do? Follow the algorithm. Create a memory for a node. Okay, so first we have to create the memory which will have the data that we will get from the user. Let us assume I am getting from the user is giving some value. Okay, they are giving some value, 51 or like that they are giving. Okay, let us assume they are giving 51. Okay, then next should be, this is the data part, this is the next part, this is the node we are creating. Okay, and node of next should be the head value. What is the head value? 1000. Okay, so the meaning is it is connected like this. Okay, now what is the thing we have to change? Only we have to change the head. What is the head value? Head value should be the this new node value. Why? This is the, we are inserting at beginning at the first node. So head should be pointing to the first node. Let us assume this address is 1016. Now we have to change the head value. See, assign head equal to node, this new node. Because of this one, head will get the new node address 1016. So instead of 1000, it will have the 1016. So it will be connected to this node. Now how the linked list is there? It will be connected to, this link will be removed. It will connected to the newly created node. Newly created node will be connected to the 1000 node. 1000 node is connected to the 1008. Like this, the insert operation will be done. Only this 2 lines code is enough to have the insert at beginning. Okay, we will see the algorithm. Before that, let me erase this one. I will give you code. I will show you code so that you will understand how we are creating the node, how this algorithm is converted into the code. You can understand. You can see. Okay. See, first node is created when with the help of the one constructor. First the class node is created, then we are having the constructor receiving the data and the next. If there is a data is not received, none will be assigned. Okay, so whenever we are creating the object for this class, it will create the node like this. It will have the two part. One is the data part, another one is the next part. This one, this variable, one is the data part, another one is the next part. These values we will receive from the user. Okay, so this create node is nothing but this one, and create head with the node value. So again we are creating one more class. After this class we are creating the one more class. Here we are creating the head with none value. You can see We are having the constructor we are creating the head will initially assign to the none, because as per algorithm the initially the list is empty, so we are creating the head node with the none. Okay, then see this algorithm, insert at beginning, create a memory for node. Okay, so here we are defining the one function insert at beginning. Here we are creating the node equal to node. What is this node? This is the class. So we are creating the object. This is the object for the node class. So whenever we are creating the object, this constructor will be called. So it will create the node like this. Okay, so when I am executing this line, this will be created one node. Sorry, this will be created one node like this. Okay, with the data and next. How it is getting the next? Because of this part. This node class will be called and it will create the constructor. It will have the data and next. We are passing the some data. This data is nothing but received from the user. The user may give 10, 20 and so on. So we are passing that data over here. Then we are having the self.head. What is self.head? Head is nothing but none. So initially head is none. So none will be assigned. This case, none will be assigned. Then we are giving the node to head. Okay, so the node address may be the 1000 and head is already none. Here instead of the none, it will be changed into 1000. So it will be linked like this. This is the case A. Case B also, see in this case also, first we are creating the node with the head value. What is the head value? Initial 1000 will be assigned over here. And we are giving head equal to node. This head equal to node, the newly created node, 1016. This address is given. Okay, this address is given. Okay, so this 2-line code help us to insert the node at beginning. Hope you have understood this one. So what we have to do, first we have to create the node, which should a node class, we should have the constructor. The constructor having the two variable, one is data and another one is next. Then we should have the linked list class. That class should have the one constructor and that constructor have the one variable, only head. Initially we are assigning with the none, because initially the linked list will have the empty, so head should be the none. Then the same linked list class will have the insert at beginning function, only 2-line code. Whenever node is created, data should be there and the next value. This is the next value. This is data. This is next value. Okay. See, whenever you are creating the constructor, it will be called this one. Okay. That is why this is having two variable, data and next. Data will be given from the user and head value will be this next value. Okay. This is how we have to write the code. And next we are going to see about the insert at the end. What is insert at the end? I will show you. Already here also two cases are there. Okay. First we have to check if we want to insert at the end, we have to check head is none or not. Why? If head is none, what is the meaning? List is empty. If head is none, then list is empty. Then what we have to do? We have to create the memory for the node. Okay, create a memory for the node means some data will be come into the data part. What will be in the next part? The head value. What is the head value? None will become. As per, okay, as like a previous one. Then we have to assign the head equal to node. Let us consider this node address is 2000. Now we have to assign head equal to node. So head will have the 2000. Okay, so this is what we have to do in the first case. If there's a list is empty, just create a node and assign the newly created node as a head, so that it will be created like this. Okay, otherwise already some nodes are there. Okay, for example, already some nodes are there. I will show you. You have to listen very carefully, then only it is easy to understand. Already some nodes are there like this. Head. Here what will come? None will come. The head will have the address of the first node, 1000 will be there. Okay, now I want to insert at end last node. So what I have to do, I have to find the last node, then here I have to change the address of this node, this place, then I have to bring the new node. How can you find the last node? Yeah, whenever the node of next is having the none, then we can say that is a last node. This is not last node because it is having the address. So this is not a last node because this is having the address of the some node. So we'll take this node having the none in the next part. So this node is the last node. Okay, so what we will do? We have to find the last node. The last node is the node which is having the none. So in this to find this last node, I am going to use the one monkey over here. So what is monkey? What generally monkey will do? It will jump from one tree to another tree or one branch to another branch. So our monkey also will start from the first node and it will jump to the next node, and again it will jump to the next node until it is reaching the last node. Okay, so for that reason I am using monkey. So what is initially monkey? Monkey will is nothing but the head value will be assigned to monkey. What is the head value? 1000. Okay, now initially head is pointing to 1000 node, monkey also pointing to the 1000 node. Now we are going to keep moving the monkey to his next node until it reaches the last node. So how do we know it is last node? Until if there is a none is there, we will stop. If there is a not none, then monkey will check here whether the monkey of this is monkey of data now. This is monkey of next. If the monkey of next is not none, the monkey will go to the next node. Then it will check monkey of next. Monkey of next is not none, means monkey will jump into the next node. And it will check monkey of next is not none, it is a none. So monkey will stop here. Then we will identify the node which is having address 3000 is the last node. Once we reach the last node, we have to create the new node. We have to create the new node like this with the given data, and this will have the none. Then let us assume the address is 4000. Now what we have to do? Here this none should be removed. The address of this node should come here. So what will happen? This will have the link. That's it. Okay, how do you change that? This nothing but monkey of next. So we have to change the monkey of next is the newly created node. Here I have changed it right like that. So if we want to insert at last, we have to check whether list is empty. If it is empty, very simple, we can create the node and we will assign the newly created node into head part. If it is not empty, what we have to do? We have to use the monkey. Monkey will go up to the last node. When it reaches the last node, we have to create the new node and we have to change the monkey of next this place into the newly created node. So the link will be created. Okay, so here the code as given, you can understand. First we are checking the list is empty or not. How do you know list is empty? If head is empty, the list is empty. If the list is empty, we are creating the new node, and new node of data we are receiving. New node of next is nothing but head. Okay, let us assume this is the new node. The data is coming is 60, and what is head? Initially head with the none. Because of this condition only we are running. If head is none, the new node is created like this. Here second part will be assigned into none. Okay, so new node will be created. Then we are changing the head into node. Let us assume this is the 2000. So here we are changing into 2000. The link will be created. So this is also insert at last when there is a no node is there. Okay, but this case is failed means already many nodes are there. There are many nodes are there. So we have to identify the last node. So for that reason we are using the monkey concept. Okay, I am giving the one more example quickly so that you may understand. Let us assume we are having the linked list like this. So if it is so, this first case will be if will be failed. So we will create the one monkey. This is monkey. This monkey value is head. What is head? 1000. So monkey will be pointing to 1000. We are checking until monkey is next. Monkey of next is having some valid address. Then if it is so, it will go to this while loop. It will check monkey of next. This is data next, data next, data next. Okay, here please listen carefully. Here we are checking monkey of next. What is monkey of next? Monkey of next is 1010. Okay, by using while. So this is 1010. This is having some valid address, so it will come into loop. In this loop we are moving the monkey equal to monkey of next. Okay, what is monkey of next? 1010. So this value will be changed into 1010. This value is changed into 1010. So the meaning is the monkey is 1010. It is pointing to here. Now it will check the while monkey of next. What is monkey of next? 1020. Second iteration. Okay, it will check the 1020. It is also valid. So what it will do? It will change monkey equal to monkey of next. What is monkey of next? 1020. So it will change the monkey value into 1020. So it will be pointing to next node. Now it will check while none. It is not true. It is not a valid one. So it will give you false. So this loop will be break. It will come into this line. In this line we are creating the new node. See the code with the data given from the user and the none. We have created like this. We have created the 40. We created the node like this. Then here we have to change. Let us assume the address of newly created node is 30. Now this place should have been changed. What value should come? The newly created node. What is this name of this place? Monkey is pointing to 1020. So this is nothing but monkey dot next equal to newly created node. What is newly created node? This node. So this node will come 1030. So here it will get the 1030. So the link will be created. So now we have inserted the node at the last. Okay, hope you have understood. If you are not understood, kindly listen one more time, and if you have any doubt you can ask in the lab. Okay, the next case, insert at the specific location in the list. Okay, after the sum node. For example, we are having the linked list like this. Okay, we are having head. Okay, let me have the addresses 100, 200, 300, 400. Here address is 100. Some value I am giving. So here address will be the 200, 300, 400, none. Okay, for your understanding, okay, this is pointing over here. For your understanding, I am going to give the node number. Okay, node number index. Okay, this is the 0th node, first node, second node, node 3. If I want to insert at the node 2, okay, I want to have the one new node and it should be inserted as a second node. Okay, that is called as a, maybe this value is 26. If you want to insert as a second node, then it should come over here. Am I right? It should come over here. So this is called as insert at middle. How can we do it? We have to get the which index we want to insert. For the example, I want to insert at 2. So they will give you the position 2. And which data should be inserted? They will give you the 26, this value. Okay, so we have to create the node like this and it should be inserted here. If I am inserting here, what are the changes should happen? Let me have this addresses 600. First, this node we have to identify. We have to come into the position 2. Then this value should be come into this 300. So it will be connected. And this 600 should be come over here. So that this node will be connected. Okay, so that this link will be removed. Okay, so the node will be look like this. Okay, so this is how we have to do the insert at middle. Again, we have to use the monkey concept. Okay, so we will see how to do it. First, we have to get the index. The index is less than 0, means the user is asked you to insert at position -1, means it is not a valid. We are going to raise the exception invalid index. Or they are giving here in this example, if they are giving the insert at 10th place, but there are only 4 nodes are there, so that also not possible. So we are going to check the index with the length of the linked list. This is the code to find the length of the linked list. Just go through it. By using the monkey concept, we are counting how many nodes are there. Okay, so this will give you length. So for here it will give you length is 3. Okay, if it is more than 3, then it will give you the invalid exception. If okay, this is the condition we are first checking. Second one, if they want to insert the node at the 0th position, index means the position. If you want to insert the position 0, then it is nothing but insert at beginning. We will call the same function insert at beginning. Okay, then we will return, we will stop the execution. Otherwise, we are using that one more variable count. Initially, we are going to count one by one. For count, this node is 0, 1, 2, like that we are going to count. So we are assuming that count equal to 0. C is indicating the count. Okay, then we are assigning the monkey again. Monkey will come. We are creating the monkey node. Okay, monkey value is nothing but head value. What is the head value? 100. So it will be pointing over here. Until monkey is there, until some value to the monkey. Let me give you here. While monkey. What is monkey? First, what is the monkey value here? 100. So 100 is some valid number. valid address, it is not none. So it will come into the loop, it will check the count equal to, what is count? 0. Okay, 0 equal to index minus 1. What is the index they have given? We want to insert at the second position, that is the index. Okay, see, they are giving it as a 2. So index is 2. It will compare the index minus 1. 2 minus 1 is, sorry, 2 minus 1 is 1. It will compare 0 against 1. Because we have to first we have to go to this location, right? Then only we can insert the node. So we are trying to moving here. So if it is so, we have reached the correct place. If it is not there, this code will not be executed. We will move the monkey. Monkey equal to monkey.next. What is monkey in our dot next? 200. So monkey will be pointing over here. And we are increasing the count equal to count plus 1. What is the count value right now? 0 plus 1, count will become 1. Again it will come and check 1 equal to 1. Yeah, this condition is true. This condition is true. The meaning that we have reached this position. Monkey is now this position. Here only I want to insert. So now I am creating the new node. I am creating the new node. Okay, I am creating the new node with the sum data. Data is 26. And what is the next value? Monkey.next. What is the monkey.next? Initially it is a 300. So it will get the 300. See? So this is pointing to node 300. Then I have to change this place. What is the name of this place? Monkey.next. I am going to give monkey.next equal to newly created node. What is the newly created node? 600. Okay, so it will be changed into 600. This line. This will be changed into 600. Then we are breaking. So what we are doing at insert at middle, we are finding the right node. After finding the right node, we are creating the new node with the node next. Then we are giving the newly created node into the node next. Okay, this is what we are doing over here in the insert at middle. Okay, so these three cases are available in the insert operation. The next one is the delete operation. The singly linked list deletion operation can be again performed in three ways. First way is deletion at beginning, deletion at the end, second one, and deletion at specific node. We will see what is deletion at the beginning, delete at the beginning. Okay, first we have to check the node is linked list is empty or not. If linked list is empty, we cannot delete, right? So how do you check? We have to check if head equal to none. If it is so, you can see here head is none, then we are printing list is empty, we are stopping. Otherwise, if the list is not empty, again what we have to do? There are two cases are there. Okay, for example, I will take the example. This is head. Let us assume this is head. Okay, it is looking like this. If we want to delete this node, if we are deleting this node, what are the changes we have to do? Only in the head part we have to bring 2000 so that it will be connected like this. Okay, am I right? So we are going to use the temp over here. Temporarily one node is we are going to create. The temp is having the head value. What is the head value? 1000. Okay, I will delete this one because you may get confused. So initially what is the meaning? It's 1000. Here it is having 1000. Initially it is having 1000. Okay, so we are assigning the temp equal to head. This 1000 will come. Then here we have to, if I am deleting this node, I need to change this 1000 into 2000. How can I know the next node is 2000? Because of image you are understanding. But if in the coding part or computer, how it will understand, the next node address is available over here, this place. What is the name of this place? This we can call it as a, this is already we know that is a head. So it is nothing but head dot next. So this head equal to, we are assigning head dot next. What is head dot next? 2000. So head will be getting 2000. You can see it is getting 2000. That's it. Okay, then we are saying the popped item is 1000 dot data. 1000 dot data is nothing but this one. It will be printed. Okay, very simple one. Then we are giving temp equal to none, so that this address also we are removing. Okay, the next one, deletion from the end of the list. Okay, if we want to delete from the end of the list, how can we do it? Check whether list is empty. If it is empty, again the same thing. If it is empty, we cannot delete. Okay, otherwise head of only one node is there. This case, okay, this is the case A. If the list is empty, we cannot delete. If case B, only one node. Only one node in list. You can check the algorithm over here. Okay, check whether node is having only one node. How do you know node is having only one node? I will give you example. Case B I am giving. This is the head. If only one node, the head, this is the data, this is the next. So head of next, what is head dot next? Head of next is nothing but this point. Head is nothing but this whole point. Okay, if the head of next is none, then we can say only one node. Then we are saying that this is the item will be deleted, and we are assigning the none to the head. We are assigning the none to the head. That is the case B. Case C, there are more than one node like this. None. 1000, 2000. Here 2000 will come. Here 11, 21. Here head will become, head is having 1000. If it is so, we have to use the monkey concept. Until we are finding the last node, monkey should go. Okay, so monkey will be initially in this part. It will check the monkey dot next is valid. If it is valid, then it will jump into the next node. It will jump into the monkey will jump into the next node in this code, in this line. Before that, we are having this one small monkey. We are storing the second last. This is the second last node. Okay, we are assigning monkey equal to second last node before we are jumping. So this will be assigned over here. So that second last node is pointing here and monkey will jump. Now monkey is pointing to this node. Again it will check the monkey dot next. Monkey dot next is none. So it will come out of the loop. It will become to this part. In this part, it will assign second dot last. This portion is none. Then we will delete this one. The meaning is we are tracking the previous node, then we are changing the previous node next, then we are deleting the last node. Okay, that is the deletion at last location. Then deletion at the specified location. It is like a same concept. We have to get the index. Index is less than 0 or greater than the length of the list. We are saying that it is invalid. If the index is 0 means we have to delete the first node. So it is nothing but what we have done in the first node. we are changing the only head value. You can see here. Only one node is there, or maybe even multiple nodes are there. They are giving 0th position to delete. This is 0th position, this is 1 position. This is 1000. So if they are giving 0th position to delete, if I am deleting this node, this should be the head. So this value should come into the head. So this value is nothing but head of next. Okay, that is why we are giving head equal to head of next, so that it will be changed into 1008. So it will be linked like this. Okay, otherwise there are multiple nodes are there. It is not a first node. We have to delete the one specified node. We have to delete the specified node means again we will store the head into the iteration. The iteration will go like a compare with the count and index, like a insert at middle, and it will go into the next node. When it is reaching the previous node of the desired location, it will break. Then it will change the particular next node value. Then it will increase the count value. Okay, so it is a deletion at specified location. Okay, and search by value. Okay, if we want to search by value, again we have to assign the monkey into the head node, and if monkey is null, then we have to print list is empty. Else we have to move the monkey into the monkey of data equal to item. If it is same, we have found the item. Otherwise we will increase the I and monkey value. The monkey should go to the next position. Okay, and it has to go until the last node. Until last node, if we are not finding, we are saying that item is not found. Otherwise, whenever item is matched with the monkey data, we will stop the iteration. This is the display. Display also we will use the monkey concept. Monkey will start from first node, then it will go until the last node, and it will be displayed. See, it is started in the first node and it will be go until monkey is alive. Then it will be printed. Okay, it will be printed the monkey data. It will move on. Okay, this is the display. So these are the functions or operations are available in linked list operation. Hope it is clear.